Welcome back to third session of the ongoing workshop. Today, the session will be chaired by Dr. Amit Pandey, and our resource person will be Dr. Pooja. Over to you, Dr. Amit Pandey ji.
Good. I take immense pleasure in commencing today's session by inviting our speaker, Dr. Pooja, who is an accomplished individual with almost 2 decades of experience in imparting education and making significant contributions in the field of computer science and engineering. With a strong background in education, she has dedicated her career to sharing knowledge and inspiring others through her experience. She has delivered numerous hand-on training sessions to students, learners, industry personnel on artificial intelligence and machine learning using Python. Furthermore, she has worked with NITTR Chandigarh towards co-creation and delivery of courses for national online education portal Swayam Portal by NBTEI on smart grid analytics, implementing machine learning module. Throughout her professional journey, she has published over 90 publications, which include national and international journal conference papers, book chapters including IEEE, Springer conferences, and Scopus Index journals. The extensive body of work reflects their commitment for advancing knowledge and making valuable contributions in the field of artificial intelligence, machine learning, and deep learning. Her expertise and insights have likely been sought after by peers, students, and fellow researchers alike. Thank you, ma'am, and we all welcome you here for this session.
Thank you, Dr. Amit. Thank you, Mayor Sir, for inviting me again.
Thank you,
Even
ma'am,
though
and
I missed
welcome.
a lot of your calls and you scold me over that.
Welcome back, ma'am, again on this platform.
Yes.
And
Thank
we
you.
will enjoy your session.
I hope so.
Yeah.
So shall I start?
Yes, ma'am. Over to you.
So I will be sharing, right? Share. So I hope my screen is visible.
Yes, sir.
Perfect, ma'am. Perfect visible.
But
All right. Right?
Right,
yeah,
ma'am.
it's in full note.
Okay. So once again, thank you so much to the organizers and many congratulations to MTTF for organizing such useful and informative workshops for the students and learners across the world, I would say. I'll start my session. The session's topic is deep learning and neural network. And during the session, though the topics mentioned are quite wide, it is actually almost half a semester content, but I would try my level best to complete or touch every topic mentioned. And I have kept 2-3 hands-on sessions in between. So hopefully we'll be able to cover all. In case there will be any issue in understanding, feel free to ask questions then and there. So topics to be covered will be neural networks, introduction to neural network architecture, convolutional neural network, RNN, and AI interpretability. So we'll start with basic, what is deep learning? So deep learning, yeah.
Yes, ma'am. Yes, please carry on.
So deep learning, neural network is actually the basis of deep learning. So we can say that deep learning is a branch of machine learning that helps in understanding the problem, and it helps in understanding the problem through whatever data you enter into the deep learning model, and it tries to mimic the human brain itself. So we understand how neurons work. So as neurons work, neural networks are created artificially, and a combination of neural networks, mostly feed forward a network, is used in deep learning, apart from CNN and RN, which becomes the input layer as a whole, right? So there will be, why we call it as deep learning, because there are multiple layers in between. So you don't know, in usually when we learn neural network, we say there is one input layer, there is a hidden layer, and then there is an output layer. So that becomes a shallow network. But in deep learning, we have multiple layers of processing units in between the input and the output layer. And usually it is used to learn complex patterns from a larger or uh, huge data. This is a very common depiction of where deep learning falls in artificial intelligence. So overall, there is a domain of artificial intelligence, and machine learning is a subset of artificial intelligence, and then deep learning becomes a subset of machine learning itself. So what are the basics of deep learning and neural network? First thing, it increases the computation power, and you can use larger data sets on it. It is able to self-learn hidden patterns within the data to make prediction. So whatever you have learned till machine learning, that you will have to pre-process the data and extract the features, and then feed those features into the machine learning algorithm or model to get the predictions or classifications done. In deep learning, we do not do that part. So we can just feed the typical, I mean, ideally, in ideal case, we say that we can typically feed the deep learning model with the raw data, and in between there are so many computations, so many layers which will try to understand the pattern, starting from the very basic low level pattern and ending up into the higher, bigger pattern which makes sense out of that data. And then those patterns which are self learned by the deep learning model are then feed to the usually feed forward network, right? And then the way simple neural network works, that feed forward network works and gives the output. So this is the general scenario. So this is how it looks. We will have input layer. Input data is fed. Based upon the size of the input data, input layer number of neurons are decided. Then there can be a lot of hidden layers, and then there will be output. Again, based upon the output, the way you want the output, the number of neurons in the output layer are decided. So if we compare machine learning and deep learning, this is how it looks like. This image is taken from mathworks.org. So in machine learning, we do this manual feature extraction, and then we put the data into the ML model, and then predictions or classifications are done. If you will see deep learning, we have the raw data feeding into some deep learning based neural network. It can be CNN, it can be RNN directly. And inside this CNN or RNN, the features are being extracted starting from the low level, then higher level, and ultimately the overall features which makes sense out of the whole data. And those features are then fed to, in between there will be feed forward network, fully connected, right? So that network is used, that feature set generated from within the network is then fed to the next neural network, and then it gives the prediction. So this is the major difference between machine learning and deep learning. Now, what is the architecture behind this deep learning? So very basic unit of any deep learning model or neural network is a neuron. Neuron artificially, if we see ourselves and if we try to understand how neurons work, we will say, I don't know if Audio is unstable. Am I audible, right?
Yes, ma'am, you're
I
audible.
think, yeah. Mm. Okay. So if we'll see ourselves, the moment something happens on your skin, very simple example. Let's suppose you are punched or you are pinched by somebody. Immediately that signal travels, and it travels to the other end of, or to your brain, and then brain gives a activates it will activate another limb of your body, and you will start pressing the part it has been hurt, right? So this is the basic concept inside our system. So when we try to mimic the same thing artificially, and we have tried to create artificial neuron, same thing is happening. So what is happening is, whatever inputs are coming, there is a weightage added to every input coming. For instance, right now you are listening to my voice, so my voice weightage is more than what is happening in your surroundings. So what is happening, that input, my voice coming to your computers, having more weightage, you are able to hear it, right? So the activation is done inside your brain. So same thing happens in artificial neural network. There are a lot of inputs, various inputs have various weights. Those are fed into the neural network. It is actually a mathematical model, submission and then some activation function. So all the inputs multiplied by the weighted sum is calculated, then there is a bias is added so that we get the desired results a bit sooner. And then there will be some activation function which will get the input, whatever is this weighted sum. Now that input is fed to the activation function. Based upon the mathematical function of this activation function, the output may get triggered. There may be an output, or there may not be an output, or there may be an output which is not correct. So this is the basic architecture behind any neural network. This is simple one neuron. So when you start connecting neurons with other neurons and you start creating it in the form of a layer sequence, right? Then a one layer is created. Same way you can create another layer. Layers are interconnected with each other. Usually every neuron in every layer is connected to every other neuron in the next layer. This is what happens. So what is very important here is the activation function. Activation function actually helps to trigger or to generate the output based upon the inputs, right? So this is the basic idea. Now, okay, I'll go back. Now, another important thing here is, if the output generated, or if it is not generated, or if there is a difference in the output and the expected output, that difference, that error is calculated, that error is sent back to the inputs through back propagation. There is again a mathematics in between how that error is transferred back, and weights are adjusted so that ultimately we get the required output. There are a lot of activation functions. So basic function of an activation function is to introduce the non-linearity into the network. So whenever there will be non-linearity, it will help in learning and representing more complex relationships between inputs. On the screen right now, what you are seeing is a lot of some of the most commonly used activation functions like sigmoid, tanh, ReLU, leaky ReLU, softmax, and different activation functions have different use cases, proven use cases, that these activation functions are best suited for some particular use case. So you don't have to test and trial every activation function when you are solving a particular real world problem using deep learning or neural network. We already have that those experiments done, and now we know, for instance, that sigmoid is used for binary classification, or it can be used in output layer. In hidden layers, usually in recurrent neural networks, RNNs, we use tanh. Okay, so The formulas are mentioned. Based upon these formulas, whatever is the sum coming up, the output is generated, right? ReLU is basically used in hidden layers only. ReLU is used in hidden layers of CNNs and feed-forward neural networks. Leaky ReLU is an improved version of ReLU. It is again used in CNNs. It prevents the dying of ReLU problems. There are a lot of things related to activation functions also, but we'll not go into the depth of every right now. Softmax, you will usually see, you pick any written code on internet for CNN or anything, you'll find softmax to be used as activation function, typically for output layer in multi-class classification, right? So as I said earlier, there is a shallow neural network where we have only one input, one hidden layer, or two hidden layers and an output layer. But such neural networks may not give you the desired output, or it may take a lot of cycles of training, of learning and adjustment of the weights to get the desired output. So that is why we move to deep neural networks. I'm not going into this, what is neural network, in 2.5 minutes. Maybe when I share this presentation, you can go through that video. So what is a deep neural network? Deep neural network, see, there are more hidden layers. In fact, more than this hidden layers. And if you can see, every input neuron is connected to every other neuron in the next layer, right? So X1 is connected to A1, A2, A3, A4. This is a hidden layer. Similarly, X2 is connected to A1, A2, A3, and A4. And X3 is also connected to A1, A2, A3, and A4, right? So that means when we will be adjusting, when we will be talking about the training part of this neuron, training means nothing. Training of a neural network means whatever the difference is coming at the output, the adjustments of the weight of every layer, right? Here also, here also, here, till the starting point, right? So that means with respect to X1, there will be weight for X, weight between X1 and A1. There will be some weightage between X1 and A2, some weightage between X1 and A3, some weightage between X1 and A4. Right? So similarly, if you will see this A1 has how many inputs? 3 inputs multiplied by 3 weights, and then there will be some output. Now this output is again going to every neuron in the next layer and so on. Okay, again, the very important thing here is you select the number of layers, you select the number of neurons based upon the nature of the problem you are trying to solve and based upon the size of the data set. We'll see this in the hands-on session. Now, when we say we are training a neural network, I said that the error at the output is sent back to the till the input so that weight adjustment is being done. So if we can see, there are 3 important things happening in any neural network. First, sum of weighted inputs given to activation function inside a neuron. This is what is happening inside a neuron, right? Now, then after this, some output is being created and that output is sent to the next layer. So then again, same process is happening and then again it is going forward from input to output, right? So this is what is happening at first place. First place, something is going forward. So we say forward pass. Okay. So whatever input is generated, that is going towards the output in the forward propagation or forward pass, right? Then what is happening? At the output, loss is being calculated. What is the loss? Loss is the actual output which is expected minus the predicted output. What is the difference between two outputs? Let's suppose our neural network was supposed to learn the names of the people, right? But instead of learning Aman, the neural network has learned A-M-A, right? So there is a difference. So that difference has to be removed. How we can do that? Now, to remove this error, whatever is this difference, that difference goes back till the input layer and adjusts the weights in between. So three important steps are going on. When this error is moving back, we call it as back propagation. Very important concept in any neural network, deep learning or machine learning, right? So this is very important. So three major steps: forward propagation, calculation of the loss, back propagation, adjustment of the weights, right? So this keeps on going and going until you stop the learning or you get the desired output. So until any of these is uh, achieved, the learning keeps going. Okay. All right. I will have to clear all drawings. Okay. So there will be iteration of these things. Forward propagation, input flows from input to the output. Error is calculated at the output. That error is sent back so that weights can be adjusted to reduce the error. Weight adjustment is done to reduce the error. Error is also known as loss function, right? So these are the things which are majorly happening. Okay. Now, how does back propagation works? Input forward propagation we understood. We calculate the sum. We give the weighted sum to the activation function. Based upon the activation function, output is generated and that output goes to the next neuron and same thing happens, right? Now, how does back propagation work? Let's understand that. So let's suppose we have an input layer with two neurons, X1 and X2. We have a hidden layer with two neurons, H1 and H2, and activation function we are using is ReLU. And output layer is having one neuron Y with an activation function sigmoid. So what will happen in the forward propagation? Initially, you will have to adjust the weights. You can initialize weights randomly. Okay, so usually when we work with Python, we use random function to generate the weights. We initialize the weights with some number. We initialize the weights, then we start calculating the hidden layer activations, calculate the output layer activation, and then loss is calculated. Whatever losses come, you can calculate the loss using a loss function like MSE, mean squared error, or cross entropy. Then back propagation happen. In back propagation, we compute the gradient of the loss, okay, with respect to the output layer weights, and we do it for every layer going backward. See, we'll calculate it with output, then we'll calculate it with hidden layers, and then we will update the weights. Now let's suppose initial value of x1 is 0.5, x2 is, let me draw it, then it will be more clear. So let's suppose there is this neuron, there is these two are neurons, then two hidden layers, and one output layer. So right now it is this, and then from here, right, and then this and finally the output generated. So there will be some input. Okay, so this is x1, this is x1, this is x2, right? x1 is 0.5, x2 is 0.2. Now what are the weights? Weight 1, this is W1, then this is W2, okay? And then this is W3. I'm writing it very badly. So weight between x2 and hidden layer 1. This is hidden layer neuron 2. So weight between these two is W3. This is W4, and then there is weight W5 here, which is 0.7 from hidden layers neuron 1 to output, and there is a weight between hidden neuron 2 to output, which is minus 0.3, right? Now we'll calculate the activation function. Now we said we have activation function as ReLU. Now let's see what is ReLU. ReLU is what? Okay, here. So ReLU is nothing but max of 0 and x. Okay, here. So basically what is happening, ReLU is being applied on the sum of weighted inputs. So what is the sum of weighted input? 0.5. First sum of weighted input will be this 0.5 multiplied by 0.4, then plus this multiplied by this. On this is happening, right? And then ReLU will be implemented and output is generated. Let's suppose it is 0.18, right? Similarly, for hidden layer neural network 2, same thing is happening. Now in this case, what is happening? 0.5 multiplied by 0.3, this this, and then 0.2 multiplied by 0.2, which is coming from here. So these two are calculated, and let's suppose the output is this, right? So hidden layer 1 neuron has a value 0.18 and 2 has a value 0.19. Now what we will do? Now we will try to check the weights of the output. Now at output we are using sigmoid. We have used sigmoid. Now what is the weight of this between hidden H1 and output? It is 0.7. So we are using 0.7. The value is 0.18. 0.7 multiplied by 0.18 plus minus 0.3, this one, multiplied by this value, right? And the output is approximately 0.517, right? What is our target value? Our target value is 1. So what is the difference? Difference is calculated like this: half of target minus output generated whole square. So what is my difference? Difference is 0.116. Now what will happen? This is the forward propagation has done. Now forward propagation is done. Now we will move to back propagation. Now we have to take back this 0.116 error back to the first layer weight so that those values can be updated. Now what we will do? We will compute the gradient. Now gradient is nothing but the with respect to output first, right? So output is y, so we will calculate gradient curly loss by curly y. So which is nothing but the difference y minus t, which is this, minus 1. T is 1, right? So this is my, so we will again there was, now this is first weight, then for hidden layer we will calculate it again. It will be now for hidden layer, what is the loss? Loss is coming from y and with respect to its weight. right? And multiplied by the sigmoid itself. So based upon this, we will calculate it, and then weight will be updated. Now, how weight will be updated? The new weight will be initial weight minus learning rate multiplied by the gradient. This is what is the updated weight. So we'll do it in the notebook also. Let me just go to the notebook itself, and there we will solve it here only. I have already opened this Jupyter notebook. This is simple. So right now we'll try to create this simple 2-layer neural network. Is my screen visible?
Yes, ma'am. Screen is visible. Can you please increase the font size?
I will increase
Yeah.
that, sir.
Yes, ma'am.
I hope this is visible enough,
Yeah,
right?
it's fine.
Yeah. So now we will try to create, we will not use any library of neural networks. We'll try to create from scratch 2-layer neural network to demonstrate how it can be done, and we will be using the XOR problem, right? So what is an XOR? XOR works like this. If there is one input x1 and there is another input x2, and there will be output. So if x is 0, x1 is 0, x2 is 0, output is 0. If it is like this, 0, 1, output is 1. If it is 1, 0, output is 1 again. And if both the values are 1, output should be 0, right? So what we have done, we are using NumPy to create this data set. So what type of data set we need now? We need inputs. These are my inputs, and we need output data, right? So here, if you can see, we have created the sets of all the 4 possible inputs: 0, 0, 0, 1, 1, 0, and 1, 1. So 0, 0, 0, 1, 1, 0, and 1, 1. This will be this is created in the form of an array, right? So this will be my x. X is nothing but the input data. Now I'm generating y. Y is what? 0, 1, 1, 0 corresponding to these values. So corresponding to this 0, 0, I have 0. Corresponding to 0, 1, I have 1. 1, 0, 1, and 0. Done. So this we have generated. Now what we will do, let me just run it. Now we will initialize the weights, right? So we are saying input, what is the size of input? 2. Size of the hidden layer? 2. What is the size of output layer? 1, right? So we are generating weights W1, B1, W2, B2, right? So W1 is some weight will be generated based upon the input size and the hidden size. Some bias is being added. Bias is B1 is, again, I'm using random.rand function to generate all these weights and bias, right? Now see, this W2 is between hidden layer and output layer. So first there will be an array for weight between input size and hidden layer, right? So I will generate this. I have run this. Let's see what is W1. Oh, why W is capital? See, all weights are generated, right? So we have random values. So why do we need 4 weights? Because there are 2 neurons at the start and 2 neurons at the end. So it is neuron 1, then neuron 2, and there is hidden layer 1 and hidden layer neuron 2. So why these weights are required? Because these weights will be there will be one weight required from N1 to H1, N1 to H2. Two weights are done. Now I will also require two weights for N2, connecting both the layers. Done. Just wanted to show you how we have created this, right? Now, what is the next step? Now I need to calculate the loss function, right? So nothing. We are using sigmoid and sigmoid derivative to activation function and loss function I have generated. So just creating a function. Sigmoid is nothing but 1 upon 1 plus whatever is the value 2 to the power minus x, right? And this is what we are generating is the sigmoid derivative for loss function. Now we have to calculate the forward pass. What is happening in the forward pass? In the forward pass, we are multiplying the weight with the input, then some bias is being added, right? And then whatever is the summation, upon that sigmoid is being used and then output is generated. This is for the hidden layer. For output layer also, we are using same. So what will be the output of forward pass? Output of the forward pass will be the hidden layers output and the output of the whole neural network, right? Now I am calculating the backward propagation. I am trying to create that function. Now how backward propagation was happening? First we had to calculate the error. We are calculating the error, right? Now in between hidden layer and the previous layer, again there will be some output calculated that is being generated. Now I am using, okay, this is the loss gradient for the output layer only. Output is generated, output gradient is being generated. Now we are using gradient loss between the hidden layer. For hidden layer, what is the output and what is the gradient? Then how my weights were updated? My weights were updated using some learning rate multiplied by the previous weight and the loss function. So simple calculations are done. Now this learning rate, here we are saying learning rate will be 0.1. You can tweak it, you can use different learning rate and try your hands on this. Epochs we are using 1000. Now epoch is nothing but how many times the learning will happen, right? Whole process, forward, loss and backward, same. So what we are doing, in each epoch what will happen? Forward pass is to be happened, backward pass to be happened, and ultimately loss calculation has to be done for every epoch, right? So once we will, let me run this. Now we will run this and you will see everything is being calculated, right? Now let's see what is the output. Predicted output for the expected, what was the input? 0 0 0 1 1 0. Now see what was my input. Input was 0 0 0 1 1 0 1 1. See, there are four outputs if you can see here. And what is the first output? First output is, what is my first output here? First output is 0.057. So I can say that it is 0. Next is 0.947. So we can say it is near 1. Then 0.47 and 0.41, right? So you can change what you can try. You can change the learning rate. You can check. You can also check what are the weights. If I will see this, no, this is nothing but for weights. See, these are the weights. What were the initial weights? Remember, we checked initial weights. For W1, it was only this much. Now it has changed. So because weights have changed, the output has been changed. So you can tweak it, you change the learning rate, you try it again and see what happens. You can change, try your hands later on when this will be shared. You can convert it into AND gate and see what happens. You can convert it into OR gate and try your hands and see what happens, right? So this is how you can generate a simple neural network from scratch. Because this was only 2 by 2 layer neural network, it was very simple. But usually what we do, we use TensorFlow. Now let's see how TensorFlow will ease our life when it comes to uh, working with neural networks or neural networks, right?
Ma'am, excuse
So
me.
yeah,
I think we should ask some questions from the participant for this previous
sure.
model. Dear participant,
I
if
am
you have
opening.
any question for the model which ma'am just present here, because this is a very scratch and this will help you to understand the
Basic
more
thing.
complex problems. Yeah, but this is the basic thing. So if you have question, you can unmute your mic and then you can ask your question. Please, over to you. Any participant, if you have a question. Or
Yes,
either you can, yeah,
I
so
have one question.
Please, sir.
Uh, yeah, ma'am, we learn that is backward propagation, forward propagation, everything. So this is a part of a deep learning. I think this is very complex and very large database, and so we need GPU, high level GPUs for this one. So I think deep learning is
Definitely.
everything connected with I think big GPUs like something. It is connected with each other. How?
Sir, so deep learning works on huge data sets. You are very much correct. We cannot run it on simple CPU. We need GPUs. Usually we need GPUs when it comes to, so usually CNN works on image data. Image data itself is very complex. What I am showing you is just implementation of simple neural network. And if you will see the data here, it was only four values. So I was able to do it here. But when it will be huge data, I will show you something on MNIST data also, and you will see it will take lot of time, right? So what I am trying to present to you is something which you can understand during the session, and it may not take much time as well. Have I answered your question?
Yes, yes, it means if we have large data, then we have need to for deep learning. So we need a big and large GPU as well as if we have a
Yeah.
large
So
data.
there are, Saurabh sir, there are some platforms available. You don't have to buy things. You can, I hope you all understand what is Kaggle. So you can create your accounts on Kaggle. Kaggle provides good GPU support, right? Another is Colabs, Google Colab. I was not, I'm actually sitting in my organization and Colabs are restricted here. Otherwise, I would have shown you all this on Colab with huge data. So Google
Okay.
Colabs you can use. It also gives a lot of free services when it comes to GPU, right? There could be others also, but for the time being, I'm just showing you, telling you that you can create all this on Kaggle. Kaggle gives you a lot of service in terms of running, huge data with tensors and working on CNNs, right? And Google's Colab is so quite famous, right? Have I answered? I think you are mute and you are speaking, sir.
Saurav, is
Never?
it clear? Uh, Mr. Saurav Kumar, is it clear? I think he is muted and not able to unmute.
It's okay.
Yeah.
So the purpose of this was to make all of us understand how forward pass and backward pass or propagation works, and how neuron networks works exactly, right? So can I move ahead, Meher sir?
Uh, Participant, if any more question, please. Yes, ma'am. Please go ahead.
Okay. So now we will try to do same using TensorFlow. Sir, I'm shutting down this video, right? Okay.
Yes, ma'am.
Okay. So now we will do same thing but using TensorFlow. Now TensorFlow is what? TensorFlow is a very good library which works on this deep learning. For deep learnings and all, you should try using TensorFlow. So you can install Tensor. Let me first show you. TensorFlow. So you can get tensorflow.org, go there, download it, install it, and then you can use it. All the steps are mentioned here, how to install it on what, right? So for Saurabh and other participants, you can go to Colabs from here, Google Colabs also, right? So this is where you can get your TensorFlow. And here I am right now, right? So once it is installed, you can use pip install TensorFlow on Conda. And if you are directly installing it on your Jupyter notebook, you have to use this exclamatory sign. So you can install it. I will run it. So first, once installed, I'm importing TensorFlow. Again, I'm importing NumPy. Okay, this is done. Now we will see. Again, I'm using XOR data, same inputs, same output. Now, in TensorFlow, there is Keras. Keras is a library actually, and you will find a lot of models available, like those are available in sklearn, right? For machine learning. So here I'm trying to create my model. Now here itself, I will create the hidden layer and the output layer. So see here, dense is nothing but a layer, right? So I am calling the model sequential model. Sequentially it will work, one layer, second layer, third layer. Then I'm creating the layers inside this model. What are the layers? I'm calling from TensorFlow Keras layers dense. Dense is the layer which will be having 2 neurons. Input shape will be 2, activation function is value. And then with one neural network, I'm saying there will be only single neuron, another layer, and sigmoid will be the activation function. This is done. Now I have to compile it. Very simple step. Whatever name you have given to your model, you call compile function on that. Now, when it comes to deep learning, we try to use optimizers, right? And there are a lot of optimizers available. For instance, Adam is most commonly used. So Adam optimizer, I'm saying in this compiler, use Adam. The loss function used will be binary, cross entropy, matrix used for verifying uh, the output is accuracy, right? Simple things, very basic things I'm creating. So what is the command? Command is model dot compile, and you need to use some optimizer to optimize the results. Next is, now you have created taken the input output, you have created the network, the model, you have compiled it. Now you need to train it. Now how to train it? On the same name of the model, use fit function. Now what you are going to fit? You need input, you need output. How many epochs do you need? What will be the batch size? you can use this 0 if you don't want to see what are the results and losses in every epoch, right? So it is verbose 1 will give you everything mentioned there. So I will show you here. See, what is the loss in first? What was the accuracy in first epoch? How much time it took? What is the loss of second? And so on. So had this been 0, this would not have been the output, right? Now see, what is the accuracy level coming as of now? It will keep going till 1000 epochs, right? We'll keep waiting. It has reached to almost there. There are other concepts also in deep learning. You can drop out, you can stop, like pre-training, you can stop it early. A lot of other concepts are also there. Again, when you will compile it or you will fit it, you will have to mention everything there. So you can go to TensorFlow's documentation and you can see what is the label or what is the command you can use for it. Now see here, until now it is 0.75 accuracy only, right? So it has not increased, right? Okay, let's see evaluation. Now we are evaluating. What is the accuracy? 0.7. Let's try to predict. Prediction. This is the output. It was supposed to be 0, 1, 1, 0. Now it is 0, 0, 1, 0. Right? Now what we can do to improve it? We can increase the epoch size maybe. Let's try to do that. I'm saying the learning should be for a more epochs. I'm running it again. It will take not much time. It is still 75, 75. I think it should go to 1 now. When I was testing this earlier, it came to 100% accuracy. Probably near after 1000 it will come. So all learning is going on again and again. What is happening in learning? Weights are being adjusted with the difference, whatever loss is there. All right. It is still 75, not much difference. 75, 75 accuracy. Same. See, nope, it is not changing. So maybe you can try later on and it will come up to 1. So earlier when I was doing it with small changes, it was the accuracy changed and it came up to 100%. It is 75 only. I don't think it will move ahead of this. So that is it. Again, we will see. So let's see what is the prediction. See, this part has changed. Earlier it was 0.84. Now it has come to 0.97. So maybe if you will increase, I will remove all the outputs and we'll try to run it again with epochs of 2000 and we'll run it quickly. It's starting with 50 accuracy. Earlier, when we changed the epochs, it started with 75 because we did not clear it. The kernel was using the same previous training of 75, right? It has come to 75 so quickly this time. Meanwhile, you people can check Kaggle or Google's Colabs. Google Colab can be seen in your Gmail itself. When you will go to more services, you can find it there. So again, what are the major things happening in this? Three major things. Forward propagation, where weighted sum of all the inputs multiplied by the activation function is forwarded to the next neurons in the layers one by one till the output. Then at the output, what do? We calculate the loss function. Then that loss function is propagated back using derivative, right? Derivative of the loss with respect to the output layer, then derivative of the loss with respect to what? With respect to the hidden layer, and then weights are adjusted. Weight is what? Nothing but the previous weight, and there is learning rate multiplied by the loss. That is how weights are updated. We should have just stopped it there only. Nowhere it is increasing. Okay, we'll see this later. Going back to our next topic, okay? We'll check this later. All right. So this was the simple demonstration of neural network. I showed you this. What are the weights connecting sigmoid function? This already told. Hidden, how it was created, how backward pass was created, training was done, prediction, and using TensorFlow also we have completed. Yeah. Next is convolutional neural network. We'll talk about this. Let me do this. Okay, it's not coming. We'll just stop this. Again, now see the second corresponding to the second pair of inputs, the output is now 1, but for not others. So maybe you can try and change the activation function or do something and it will come up, right? So this is how TensorFlow works, very simple things. Now we'll go to CNN. So convolutional neural network is again a type of deep learning model, which is basically more oftenly used for images, right? So we feed the image and it tries to extract the patterns inside the image, starting from a simple dot to edge, then lines, then corners, and then coming up to the whole object, right? The main applications of this is in object detection, computer vision tasks only, right? So this is how CNN works. Now CNN, as I told earlier, CNN is deep neural network. So in neural network, we have input, hidden and output layer. We usually extract the features and then feed the features to the input. Here, see, directly the input is fed to the input. There will be an input layer. From input directly, it is going to the convolutional layer. So there is convolutional layer inside it. Convolution is, do you understand convolution? People from digital image processing background knows what is convolution. Okay, if we'll talk about this in the next slides. I'll let you know what it is. And then there is a pooling layer, and then whatever features are extracted from these hidden, there are a lot of hidden layers in between. See, a lot of pooling layer. Then there is a fully connected layer of neural network. Then the output is being generated. right? So in convolution layer, what is happening? The way we do it in digital image processing, same thing is applied here. So there is a convolution function which works on the pixels of the images. So same thing happens. It is like applying a filter on the image. Now every time you can have multiple hidden layers in between the convolution layer, which can have different filters to detect different types of patterns, and it will generate a feature map from that image. So what does it generate? It generates feature map, right? Now what will be the size of the filter? What is the size of the feature map? That depends. You can fix it, but ultimately how many features are generated and what will be the size of this input layer of fully connected layer depends upon the number of features generated. And here, how many number of features will be generated? That depends upon the input layer, input number of, what is the size of your data, right? Now, after convolution layer, in every this, there is again an activation function. Now, activation function does the same thing the way it was used in previous neural network. It will introduce the non-linearity into the network so that the learning is happening. Commonly used neural filter activation function in convolution layer is ReLU. Then there is a pooling layer. Now in pooling layer, what happens? Now when features are generated out of this, so there is a huge data of feature maps itself. Now pooling layer will try to reduce the size of that feature map. So there are different types of pooling techniques: max pooling, average pooling. Usually max pooling is used. So in max pooling, what we do, whatever is the size of the feature map, whatever are the features, out of those features, the maximum value whichever feature has or the pixel has, that is extracted. After this pooling layer, there is a fully connected neural network, right? Now this will do the same thing, same classification or regression based upon whatever features are connected, right? Now inside this convolution layer, there are some calculations happening. What are those calculations? Number one, there will be an element wise multiplication of filter. Filter is nothing but kernel. So whatever is the filter, let's suppose this is my filter. Filter is of size 2 by 2, right? So there will be some values inside it. Let's suppose it is 1, then there is 0 value, then there is 1 again, then again 1. Let's suppose these are the values inside this filter. And then there is image also, right? Now this filter will work on the whole image one by one. So first filter will be here. There will be multiplication of each element of this filter with the respective pixel on the image, and then sum. So there will be element wise multiplication of filter with the region of the input image, and then it will be added up, right? Once this is done, there can be two different phenomena inside. So one is the filter, which is also known as kernel. Another is stride. Stride means there can be, okay, let me show you here also. Let's suppose these are the pixels of the image itself, right? And if we are saying the stride is 1, right? These are the pixels of the image, and we are saying the stride is 1. Stride 1 means, let's suppose this is my filter. So filter will start from here, first pixel, then it will go to next consecutive filter pixel, then next pixel, then next pixel. This is stride 1. Now what is stride 2? Stride 2 means it is skipping 1 1. So first it is starting from first pixel, then it will skip 1 and go to the second pixel in the image, then to the next second pixel here. So this is what is stride is. Stride means what? Stride means number of pixels the filter moves across the image horizontally and vertically both, right? Then there could be padding. Padding is nothing but adding of zeros around the image so that we can control the output size, right? These are the important concepts in convolution layer. Now this is, let's suppose this is an image, grayscale image 1, 2, 3, 4, 5, 6. These are the values, and this is my kernel. Now kernel has a value 1, 1, minus 1, minus 1, right? That means it is trying to extract the what? It is trying to extract the lines from the image, right? Now what will happen? We'll place it on the top. Now here this corner, we'll multiply each, we'll put the stride of 1 and we'll keep moving it. So we will multiply it. This is a convolution symbol. This will be the result. So 1, if you will see here, this 1 multiplied by this 0, this is dot here. 1 multiplied by 0 plus 2 multiplied by 1, this 2 multiplied by this 1, this 3 multiplied by this 0, then plus 4 multiplied by 4, 5 multiplied by 0, 6 multiplied by minus 1. There is dot in between, okay? It is not 41 or 30, it is 3 point. Not point, dot product, right? This is what is happening in this. Now after this, this will be the output. So this was the image. After first filter, this is now the output. See the difference. 1 has become minus 3, right? Now what will happen? This is what, nothing but a feature map extracted. Now next is pooling. Now what will happen in pooling? This is the feature map. We will use again a filter which is known as now pooling filter. And let's suppose stride of 2 is being happening. So we will take 2 values, and then out of these 2 values, whatever is the maximum value, because we are using max filter. So see here, what we are doing? These 2, what is the maximum value? Minus 3. These 2, what is the maximum value? 3. These 2, 6. 6. Out of stride of 2 and 2 by 2. This, out of these 3, 4. What was the value? 3. Then out of these, what was the value? And then out of these, what was the value? And so on. So this is how we will, not we, the neural network will do it on its own, right? After this step, now see, the feature map is again 2 by 2, right? It is 2-dimensional, but my fully connected neural network has 1D layer of neurons in the input. So what we will do, we will flatten this feature map into 1D. How we will do? We'll start from this, go to the end of the row, go to next row till the end of the row. So this is what is happening inside the CNN, right? Now we will see, I'm not talking about transfer learning, how we will build the neural CNN. So there are 2 ways of building or creating your own CNN. First, you start it from the scratch, which is very difficult, right? Another is you take the pre-trained neural network, like Google Net is there, right? There are a lot of pre-trained networks are available. You pick those networks, You modify the layers as per your image data and then train it again and then predict. This is the best approach which researchers and we use for training the model. Why is it so much? Now we'll try to use CNN. We'll try to work on CNN from here. I'll open that. Let me first stop this kernel. I will stop. Okay, RNN is again here. So I'm going for CNN. Now I'm using MNIST data. MNIST data is what? MNIST data is, let me see if output is there. Okay. This MNIST data is nothing. Let me show you the MNIST data. Kaggle. This is MNIST handwritten data. MNIST other data is also there, like for fashion costumes also is there. This is but handwritten data. It is written. There are files not shown here. So there are files and every file has small images, handwritten images of 0 to, I'll go back here only, 0 to 9 handwritten digits, right? It is huge data, 60,000 something, right? That data set is there. Now what we will do, we will try to use CNN on this data. It is images. The size of the each image of each handwritten number is 28 pixel by 28 pixel. Why I'm telling this? Because we will be creating our CNN based upon that size, right? So TensorFlow itself has MNIST. We will import MNIST data from there itself. First, we have imported TensorFlow. Then we will be using sequential model. Then inside the layers, now we don't need layers, dense layer only. We will be requiring convolution layer. We will be requiring max pooling layer. We require flattening layer. Flattening, we require dense output and sorry. We will also need dropout to enhance to stop the training once the output is I mean there is no much difference, okay, in the accuracy. We are also importing to categorical so that we can convert the data into categorical data also. So first thing first, what we need to load the data. So I have run this, okay. So while loading the data, this is inbuilt function load underscore data. Which data you are loading? MNIST data. And now while loading, we are creating train and test two different training sample and testing sample here itself, right? So now we have done this. Now we will reshape our data because we have grayscale images, right? What is the size of the image? 28 by 28. And we are converting into an floating number, right? After that, we are trying to normalize it between 0 to 1. How we are normalizing? We are converting the pixel values, dividing it by 255. It will be normalized. Then every category in the output, we are categorizing it into numbers, okay, because output is also in the form of small image 28 by 28. We are converting it into numbers, right? So one hot encoding is being used. Next, we will define our CNN models architecture, right? So this is the input shape, right? Activation function this. Kernel size I'm saying 3 by 3. Convolution 2D layers 32. Max pool, again pool size will be 2 by 2 filter. Again there is convolution, pooling, convolution, pooling. Then you can include more if you want to, right? And then there will be flattening layer. Then after flattening, dense layer of total number of neurons. How many neurons will be? So we'll calculate all this. It will be 128, right? Number of neurons will be required. We are saying dropout and then output layer. This was the fully connected neural input, output layer, and that has created. Now we will compile it again using compile, Adam, loss is cross entropy and accuracy matrix we are using. Now we are saying, okay, fit the model on train of X, Y train, epochs 10. I'm just taking 10. Batch size will be 128. 128 total images. Valid, this is 2% validation. And verbose, I'm taking 1. And let's see. So epochs are being run. Accuracy is 49, 50. It is increasing. This is first epoch, right? See, accuracy is increasing. It will take time. See, accuracy has increased so much. Nothing much. After that, we will calculate, evaluate it on our test data with the predicted, with the actual prediction of the test data. We will check the test accuracy. The output of this evaluate is accuracy and loss both, right? See here itself, the accuracy has come up to be 0.98 itself. Then we will predict it on the test data. And now then we will see the predictions, first 5 predictions, right? Here I'm trying to show you the images of the MNIST data, right? Nothing simple. Matplotlib is being used to fetch the images from predicted values and then generate the subplots showing the image with size 28 by 28, right? Almost there. So in this also, if you can see, I've kept in the presentation itself all the step by steps. So first step is this, second is this, what is, how many data is mentioned here. For normalization, we have divided it by this. So converting labels into binary matrix. So 3 will be represented like this, 3 digit, right? Using hot encoding, 10 bits. Okay, if you can see here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then this is what we are using. All explanation, what max pooling is doing, what convolution 2D will do. In convolution 2D, here we are using 32 filter with 3 by 3 size. Then we are using in next layer, we are using 64 filters, right? And the size is again, what is the size? Again 3 by 3 size, right? And in between, again there are pooling layers, right? Flattening will convert 2D into 1D, right? Fully connected neural network, layer of 128 neurons is used. Why 128 neurons? Can anybody tell? It will come up if you will check all the feature maps, how it is converting, right? For this, by this size of the image. Dropout rate 5, we are saying if, just to prevent overfitting, if 50% of the, setting 50% of the neurons to set during the training. So dropout does what? Dropout in between the layers, it will skip some of the neurons, right? Randomly, it will pick. There are different ways of doing dropout also, right? Then dense layer, output layer 10 neurons is used. Why 10 are used? Because 0 to 9, 0, 1, 2, 3, 9. Till 9, there are handwritten images, right? So for each digit, we are using one neuron. And because it is softmax, softmax will give you what? It will give you the probability of class. So whatever is neuron, whatever input you are giving, what is the probability of that neuron, that input out of these 10 neurons? 0, 1, let's suppose probability 0, for 1 it is 2, and that is what will give you the output. Uh, there is compile and all. These are the basic steps we do. Okay. Something I have missed on this. So let's see what has happened. It is still working. We are at epoch 6. Meanwhile, I will do this animation correctly. This animation will go at the end. Yeah. This is there. This is there. This is there. Why? Okay, I will include it into another sheet. It will be better. So then we have compiled epochs. You can change the epochs, right? This is inside the compile what we are doing. 10 epochs are used, 128 processing 128 images only. Validation 20%. Training data is reserved for validating, and then verbose, you know, right? Then evaluation will give you test loss and accuracy both. You can print, and here we are trying to predict only the first 5 outcomes, right? These are the basic steps in CNN. Let's see. We are at 8. Soon we'll be at 10, and then I want you to see what, how the images are predicted and how it is coming up. Meanwhile, if you have any questions, you can ask related to CNN. Anybody? So epoch 8 is done. 9 is there. And see what is the accuracy is coming as 99%, right? Okay, there is one. Request to provide us the recording. Oh, that sir will be providing. I hope you will get it. So I'll be sharing these Jupyter
All the
files as well.
all the content.
All the content, yes. I'll share it. I'll be putting it on my medium.com account as well. You can get a lot of other topics also from there. I think I can share that meanwhile. So it is medium.com /@DRPL. Let me check if it works or not. Yes. So if you can see it on the screen, this is medium.com. You can get a lot of other topics related to machine learning and analytics, uh, and you can follow me here. I'm sharing it with you in the chat, and I will be uploading these files in this only. All right, so we are almost done with our epochs. Okay, so it is done. Now we can evaluate. See the accuracy rate. We will see the predictions of first 5 only. Okay, model predictions are being done for first 5 sample. These are the arrays, right? But we can see these arrays in the form of images. So this is where you will see the image. See, so 7 was predicted, true value was 7. This is the image. Such images, handwritten images, are there in MNIST data for handwritten, right? So true value was 2, it was predicted 2. True value was 1, it was predicted 1. And so on. 4 and 4. So 5 values we have checked. You can check for others also if you want to, right? So I have done nothing. Whatever were the predictions, right? Whatever it was coming, we have converted it into, that was an array only, right? We saw this was an array, right? Array, right? So what we did, this is the probability, right? If you can see in each, this is the probability of the first occurrence. First occurrence is 7. So see here, what is the probability of that for word 0, for letter 0 is 1 point something. For 1 it is 4 point something. For 2 it is 5 point something. For 3 it is probability is 1.2. For 4 1.26, and this is 7. See, for 7 the probability of having the input as 7 is 9.99, more than this, which is 9. So there is similarity between 7 and 9. See, and see the probability of first digit for 9 and for 7. So for 7 it is more, so it has given me 7 output. Same for the second image, it is saying the predicted prediction is 2. Why it is 2? Let's check what are the probabilities for 2 here in this. So what are the probabilities of this having 2? See, for 1 it is 1, for 0 it is 1, for 2 for 1 it is 1 point this, for 2 it is 9.9999 something, right? 3, 4, 5, 6, 7, 8. So 2 and 8 are quite, when you write with handwritten, sometimes it can be tricky whether it is 2 or 8. So see, for 8 it is 9.0, but which digit, which neuron has the highest probability? The neuron at 2, right? So the output image is 2. Got it? So this is how. So softmax will not give you the exact output. Softmax will only give you the probability. And why there are 10 probabilities? Because there were 10 different digits, and we said our output here. We said our output layer has 10 neurons, each neuron for each category. Got it? I hope you understand. You are understanding what I'm saying. Any questions related to CNN? You can ask now. Otherwise, we'll move to next topic.
Hello, Prof.
Yeah.
Yes, thank you for the discussion so far. I want to know from the theoretical perspective, this data, that since they are probability generated, do we have like a formal definition of how this come about? What I mean is this data that we have.
Yeah. So
Do we have it
so
that we can find it on our own? Then the second question is, if the data is larger, you have a very large data. I mean,
it is very
models,
large data.
yes. So how long will it take to get our results based on the training given to the system? Thank
It
you.
depends. See, the data is large, but the size of the image is only 28 by 28 pixels, right? And if you have seen, while we were training it, here we were training with only 10 epochs, right? And it took some time, right? This is about your size. It will take time. Sometimes it takes hours. I remember we were working on some, through my research scholar, we were working on medical images. It took whole day for him to train this CNN. So that is why we say, instead of training it from the scratch, you pick a pre-trained model. There are a lot of pre-trained models. LexNet is there, GoogleNet is there. There are a lot of pre-trained models based upon different problems. Right? So you better pick the pre-trained model, because pre-trained models already have some features learned. And when you give it your own data, you just tweak the architecture, the layers, these layers as per your data, and it will work. Now, your first question was how theoretically I am telling you that this is the probability, right? It is the softmax. If you, okay, let me go back here to the,
Sorry, the reason why I ask is I expect it to possibly be a conditional probability or some form of Bayes theorem that is being employed. So I'm just imagining how, because before you can train such a data to acclimatize, to adapt to this, then the source of the information would be very, very important. So we are sure that what we are using our data for would give us the right interpretation and meaning as what we want. Thank you.
no, the probability is not based upon the data. It is softmax which gives the probabilities. Whatever data you will give for classification, the softmax activation function will give you the probability for that particular class. And we have used softmax, right? And if you will see the data, I might not have explained the data to you. I'll show you the data. Let me show you the data from the, so if you can see on the screen, so MNIST dataset was created by this only. I will share this with you. I'll put this link in this also. So this data has, this is authentic. This, and if you can download it from here, you can see the images. This is in lot of bytes. So if you will download it, you can open it, you can see small images on it. It is 28 by 28 pixel data. See, it is written 28 by 28 size of the image for approximately 60,000 users, or not, with their handwritten. It is cut, it is created into this size 28 by 28, and then it is put into different uh, files. So it is that data only. So when you get data, from where you get the authentic source, like this is the authentic source, you see the description of the data also, right? So what is this data? This data is for the digit 0 to 9 only. It is mentioned all in here. Got it? There is another MNIST data. I will show you that also. MNIST fashion data. I hope there will be images here. See, So this is again MNIST data, but it is for fashion. Can you see the images on the screen? Is my screen visible, Dr. Amit? Yeah,
Yes,
CNN with
ma'am,
TensorFlow.
visible.
Yeah,
Yeah, ma'am,
see
visible, ma'am.
these are small images of different clothes, shirt, trousers related to fashion. So this is this data. So similarly, I am not able to get that link where you can see the digits. That is why I showed you the digits here. So it is this type of data only. So I hope I have answered your question. Diko, have I
Thank you.
answered
Yeah.
your question?
Thank
Okay.
you. Yes, yes, yes.
Okay. Any other question or query? You can use same CNN, whatever this file on this data also, what I showed right now. But you have to check with the data. What type of images are this? Whether it is 28 by 28 pixel or what is the size of this? Accordingly, your size of the architecture of CNN will change. Okay, I would request you people to try this also. Although you will find the whole notebook here, but try to create it on your own. From here, we will come to know what is the size of this. Uh, 28 by 28. This is also 28 by 28 size. Okay. All right. See, this is the convolution created for this MNIST fashion data. Almost same. All right. So if there are no further questions, we can move ahead. I will consider it as yes. So all in
Uh,
all, what you need to, yeah.
Yes.
Ma'am, myself Nafil Ahmed.
Hmm.
Ma'am, just I had two queries.
Hmm.
Hello. Yes, madam. Ma'am, machine learning, deep learning. Uh, now I think this is Python which is used. So now my two small queries. The machine learning, deep learning. Uh, can we all in place of MATLAB, whatever the feature we will be having, can we
Same
expect
thing.
that same we can have in Python?
Yes. So
Uh,
see, the steps are same. The
okay.
syntax will be different. I think in last workshop with Dr. Meher, I presented CNN with MATLAB only. You can check that recording with him.
Yes, you
And
did
one
that.
last,
Yes.
and one
You
last
have
one.
attended.
One
I
last.
don't know when this happened.
Okay.
So
I mean,
we did CNN with
okay.
MATLAB only. So the steps are same. According to the language, the syntax may be different.
Okay. My last question is,
Hmm.
let us suppose I switch to Python. Now,
Hmm.
as you know, that MATLAB is not a free software, so we have to
Hmm.
pay that. Is coming to Python, deep learning, machine learning, that this particular tool will be free software, or we have to pay the way we go for MATLAB?
It is free.
Okay.
TensorFlow, Python, open source.
Thank you, ma'am.
Keras, everything open source is
Okay.
there.
So you
So
can
you
go
can
me.
use Colabs. In fact, Colabs you can use. You don't have to pay for GPUs and everything. You can use Colab very easily.
Okay, madam.
I
Thank you,
mean, to
ma'am.
some extent, yeah.
Okay. Thank you.
Okay. So again, the basic steps are same. Syntax may be different, but it is the concept is same. Syntax using different tools will be different. Okay. So next is RNN. So now what are RNNs? In CNNs, we have checked that there was no need of feature and all, and the data was usually image. So there are a lot of real world problems which are based on data which is sequential. Sequential in the form, in the sense like I am speaking. So I spoke one word, then second, then third. And until and unless whole words are, or for a sentence, are put together, the meaning is not understandable. For instance, chatbots, right? So you type some question and chatbot is able to understand it. How? Because it was able to comprehend what were the words and what did it mean, right? So RNN and long short-term memory networks are basically used for sequence modeling only. We say when the data is sequentially dependency in terms of text, in terms of time series or speech processing, we prefer using recurrent neural networks or long short memory networks, right? So I have put this source. This is a very good video. Just check that. So in RNN, what we do, we create input layer, there will be hidden layer, and in hidden layer, there will be recurrent connections, there will be loop, and then there will be output. Now, what that loop is doing, that loop is saving the state of the previous value, previous input, so that the context can be generated in the sequence, right? We'll see this. This is what a neural RNN looks like. So there is one neuron, some weight, hidden layer. Now hidden layer is giving something at the output layer. It is also looping it back to itself as a hidden state. So the previous output is used as an input while having the hidden state. This is what is the difference in this. And this is why it is being used, so that it can retain some memory and it can then create the context of the sequential or series or time series or speech or text. Okay. Now in one neuron only, if we are saying it is time series based, right, or it is in the sequence, it can be unfolded like this. At time t minus 1, what was happening? At time t, what is happening? At time t plus 1, what is happening? So what you saw in CNN as layers, we can say within this structure, there can be a lot of temporal calculation happening. Is this understandable? I hope so. So this is how we can understand it better. Let's suppose there is a text, what time is it, and then question mark, right? Now what will happen? One by one, we are saying that text is now segregated in the form of words. I'm not segregating it in the form of character right now. I'm saying it is correct. Sentence is segregated or segmented out in terms of words. So first, what will happen? The first text will enter into the neuron and output will be generated, right? Then next time will be entering into the neuron and output will be generated based upon this word and the previous output from the previous word. So see here, two colors telling us two words, right? Next is, now is giving some output along with all the previous outputs. Similarly with T, similarly with question. But one thing which is very important here. So this is how it is generating. And now when at the end question mark is given and neural network has learned something, it will generate all this. What time is it question mark to some accuracy. Now there is same concept. Back propagation, forward pass, same thing is happening. Now the only drawback here is as the back propagation happens and the number of layers increases, the gradient vanishes away. There is a concept called vanishing gradient. See why it happens? The loss was loss is usually in points. When it goes back to the previous layer, it reduces because it is a derivative function, right? Loss gradient is what we send back the derivative of the gradient. Derivative again reduces it. So until it goes back to the previous layered, the last layer backwards, the gradient vanishes away. So it does not contain as much information which is required to retain the previous value. That is why what happens? That is why LSTMs come into picture. Long short-term memory or gradient-based recurrent network GRN are used to retain the previous memory. What does they do? They keep one gate here like some memory, right? Which will retain the value for a longer time. Not going into how vanishing gradient happens and all mathematical, just trying to make you understand the concept, right? What are the applications of RNN? Text generation, sentiment analysis, time series forecast. RNN and LSTM same. Okay, we'll go to this. That is the last topic later on. But now we'll go to RNN and we'll try to see how those RNNs can be implemented using TensorFlow. We have 10 minutes, right? We'll try to finish this. And I'll try to show you also how RNN and LNNs are varying. So see here, from layers, I am now importing simple RNN and dense layer for the output, right? Simple neuron. Now here, not here, here. I am giving one sentence as an input. Okay? We don't need this. Maybe we need, yeah. So sentence is, hello, how are you? Hope you have a good day. Right? Now first thing, what? We need to convert this into what? Different? We are converting it into unique characters. So unique characters are sorted out from this, right? And then let me show you how this is working. Wait, what is gas? See, so out of all this, the characters are segregated, sorted out by only the unique one, because we have used set. Set will only have the unique values. There are repetition of H, there is repetition of E, there is repetition of L, there is a lot of repetition of O, but we have segregated only the unique characters. Okay, I'm deleting this. Okay, right? Then we are mapping our characters into integers. Why? Because machine will not understand characters, right? Like earlier, in earlier case, we used hot encoding. Here we are just converting it into integers. So we have used enumerate function and we are converting it into characters, integers. Now what we will do, now those are again converted into characters. Why? I will show you, because we need output also in the form of characters back. Okay. Now we are converting the sentence to the numerical format, whole sentence, right? I will use -1 here just to put the first starting from 1. Okay. Now we are reshaping our RNN input in the form of what will be our sequence length and input dimension. So we are reshaping it into 1, 1. Simple utilities are used to categorical. We are converting it into categorical values. We are saying X is this and Y is this, right? Now we are using RNN, sequential, simple RNN. I'm saying there will be 20 neurons. Input shape will be none. Why none? Because whatever is the shape of the sentence, it will take that. Okay. Till the length of the characters. Return sequence equal to true means it will keep looping it. So we are trying to retain the memory. I will show you what are the results if we will not use this also. Then there will be dense layer. Activation function for output is softmax again. We are compiling the model. We are fitting it using approx 1000. We will predict it, and then we will see what are the characters. We are rejoining the characters based upon the predictions. Let me show you. So I have compiled it. It will go for 1000 epochs. It will not work. It will work. So it's working right now. Let's wait for a while. And it is done. So what was the input was hello, how are you? Hope you have a good day. And we removed last character and the first character. What is the output? Hello, how are you? Hope you have the good day. No question. Got it? This is how powerful it is. This is simple RNN we have used. If I will say take all the characters, it will give me starting from H. Something has happened. Where is the error? Here. It will start from the beginning. So what has happened actually? Now my neural RNN has retained the previous word, previous character, and now it is regenerating it one by one. Okay. Now we can see same thing, but with what? LSTM. Okay, I'm generating this again. Now again the word is this. Same thing we are using. Oh, we use epochs 1000, no? That is why. Here I'm using gradient ARU instead of simple RNN. Gradient RU and LSTM, they take care of vanishing gradients. It will say, see, what is the output? It is different now. So what we might do, we might change the number of epochs. We might change the number of epochs, number one. We might try to use dropout here. We may use return sequences already there. So this is how you will use. So the point is, it is very simple to use it if you understand the concept and you know what is your data and what should be the shape of the input and the output layers, right? So you can use it with LSTM also, you can use it with simple RNN also, and try your hands on. Here, now I am using dropout of 0.2. Okay. Let's try to use this and see what are the results. It may take a while. Still working. So once this is done, we'll see the output. You can change the sequence, try to change the sequence, and accordingly change the number of neurons and see what is the output. See what is the output? Hello, how are you? Hope you are. Instead of doing, it is saying youing. And how are you again? Right? So how much is the output generated? That depends upon what you are writing here. I want 50 outputs to be generated. Okay. So this is the basic concept of RNN, LSTMs, There are a lot of hyperparameters you can change, you can use, like we did changed here. Again, it depends upon what data you are using, how much data you are using, how many sentences, sequences are there. Here we used one sequence of sentence. If the sequence of sentence will increase, what will increase? Here the size of the layers will increase also. Input sequence will increase. The shape will increase, right? So that depends upon your data again, I'm saying. So this is the basic concept of RNN LSTMs or GRUs. Based upon these, the transformers are created, and using transformers, you know what ChatGPT is doing these days, a lot of work. So this is this. If there is any question, please ask, else we will move to the last topic for today, that is explainability and interpretability. Just small thing.
Hello, madam. Yeah.
Yeah.
Please, I observed that time series is what is used or implemented in the running of an RNN model. Is
Same
there a
way, no?
reason?
So,
Time
huh?
series. Is there a reason why time series was used? Time series analysis. Why? I don't know why is it that it is time series that was used? Is there a reason for it?
See, CNNs, so deep learning, there are a lot of models, right? So we said CNN was one model, but CNN is good for what? CNN is good for image related data. When you have to extract objects out of the image, you have to detect objects out of the image. When it comes to time series data, you can do something using machine learning, but if you have a lot of data and you want to run deep learning on that, you want to create a deep learning model on that, recurrent neural networks are used. Why they are used? Because they are built differently. So there is a loop inside. In CNN, what was there? Every neuron is connected to the next layer. There is no retention of the previous value. So whenever there is a time series data, if we consider ourselves, right? If I am telling you very simple example, can you tell me, can you speak ABCD till Z? You can speak. Why? Because you have retained it here. You know, after A, B will come. After B, C will come. After C, D will come. You know that. Your mind has retained the sequence of that A, B, C, D, all the alphabets, right? And if I'm telling you, okay, speak A, B, C, D from backward, Z, Y, X, and so on. You may take time, but you will be able to do that, right? And in this artificial intelligence, what we are doing, we are trying to mimic how our brain works. So is there any model which can work on such data which is related to its previous temporal state? There are very less, or there might not be any model. So this, to retain the previous state, in RNN, loop is going back to the original neuron. So whatever output is going to the next layer, it is keeping it to itself also, so that it can retain the previous value. And what is the current value and the previous value, it can relate, it can regenerate it, or it can comprehend, like in chatbots for text data. Are you getting my point? Have I answered it? Why do we
Yes.
need it? We need it for this purpose.
Yes.
And other time series data could be, let's suppose you are gathering data for your farm, right? What was the weather, what was the value of moisture in the soil? So you need to understand what was the previous value, right? Then only you'll be able to work on that data. Getting my point?
Yes.
So
Thank you.
whenever, yeah, all right. So now we will quickly finish this topic, which is again not this. Okay, I think now it should work properly. Yeah. So what is AI model interpretability and explainability? we have understood that how CNN work, how RNN work. Are you able to, like, you asked me question, this participant asked me question, how is it temporal, or how is it working, or how probabilities are being calculated, or how data is being converted. So if we will see from a from an upper level, we cannot understand what is happening inside the hidden layers. So we consider neural networks as black box, right? We do not know what is happening inside, how interpretations are being done, how it is interpreting the data, right? Can we explain it? We cannot. So there are some challenges related to this, right? Now what are these challenges? These challenges are, first, to the degree to which human can understand the cause of a decision based upon what the prediction was done. Sometimes it is not clear in, let's suppose, CNN or RNN, right? Then explainability. Explainability means addressing why a model arrived at a particular decision, right? And how effectively it can be communicated to the end user or the stakeholders, how it is happening, right? So that actual what is happening is sometimes not known. So that is why we say it is a black box nature of the neural networks, right? So what is happening? These are why do we need to address these issues? Because in healthcare you cannot just say, okay, something has happened, we can use that AI model for the diagnosis, or for doing some medical operations. AI models need to be interpretable to support diagnostic accuracies so that patients are safe. For instance, in finance, for instance, in just legal systems. So you need to understand, there are a lot of cases, if you will check on internet, no, there were systems used based on AI which have failed. There are a lot of cases where innocent people were jailed because they were predicted wrongly using CNN TVs, the data on the CNN TVs. It has happened. So that is why these two are very important things. So what we do, what are the challenges, why it is so? Because there is a lot of data, there is a high dimensional data, and it becomes difficult to interpret. There is non-linearity in the activation functions itself. It is challenging to map input and output relationships straightforwardly, right? There are complex layers inside. We don't know what is happening inside the layers. It is opaque, it is not clear, right? There can be model overfitting, there can be bias inside in that. There are bias, fairness models, frameworks are available nowadays, right? So all these are challenges related to neural networks which we should address, and there are a lot of ways to tackle these challenges. And I'm afraid we are not in a position to talk about all those things, how we can counter these challenges in AI. But you should always think before, before finalizing or finally using your model for actual predictions, typically in cases of healthcare or finance or legal system, to name a few. That is all from my side. If you have any questions related to today's sessions, please let me know. You can drop me an email, or I will be sharing all this definitely. Still, if there is any question right now, you can ask. I hope I have
Ma'am,
justified with today's topic, Meher sir.
yeah, yes, ma'am. Presentation was really very nice and very informative, knowledgeable for all the participant, and a lot of things which you present here are really very useful for the beginners
Thank you.
also. And the way of the presentation is very nice, and you start from very basic level to the advanced level. That is very wonderful. Ma'am, actually, there are some participants who are beginner and but not background from the computer science or mathematics. So I think there will be some challenge to apply this technique. So can you please help some books for the recommendation so that they can follow these books and easy to learn?
Books.
Yeah.
Okay. Right now, no, I cannot. Uh, Actually, I do not know I'm not recalling the name of the author. There are good books on neural networks, on deep learning also.
Okay.
Uh, Give me time, I will include those in this only. But if online resources are required, IBM's website is very good. Go for IBM's website. Lot of data, a lot of resources are available to learn the concepts. There are free courses also. On Google, there are free courses. You can
Hmm.
have uh, like collabs itself. You will find a lot of resources related to these there also. And if
Hmm.
only books are required, then I'll have to check with the exact author name. I will let you know.
Okay, some participant like from the medical science and they are not much familiar about computing and as you present here, some mathematical functions are required which are associated
Hmm.
with these CNN and RNN. So how much the mathematics background is required for those people who want to use but not familiar with the mathematics as well as computing?
See, if I personally believe most of the clinical data is image based,
Yeah,
right?
yes.
So they should learn the basic concepts of image processing. Very important if they want to do it from the scratch to understand CNN. Otherwise, they have data, they can implement CNN, very simple. But for the in-depth learning, they must understand what is digital image processing. And for digital image processing, there is one Bible, Gonzalez and Woods, that book.
Okay.
And there are two versions of that book. One comes with only concepts, one comes with uh, digital image processing with MATLAB itself. There is a dedicated book on that also. That plus all these things, average, basic statistics are required, sir, for understanding machine learning and uh, for working on this. I mean, very basic, simple things, average, mean,
Hmm.
simple statistics is they must understand this.
Uh,
Then
dear
it will be
participant,
easy.
yes, ma'am. Participant, any more question from your side? Some of the question I ask from you, participant side because usually we got some questions like this,
Mm.
so that I ask. But still, if you have more question, please feel free and you can unmute your mic. Secondly, some of the participants asking about the content. Yes, all the recordings of this session are available, and we will provide you everything who are attending this session regularly. And the PPTs and the today's session is very informative, and some part are like Jupyter files are there. These content, as soon as Dr. Pooja will provide us, we will share all the content till day. Okay, and there are some participants who are attending the sessions through live streaming on the YouTube. Dear participant, we have shared the Google form also there. Please submit your feedback form as well as we will share the feedback form in the WhatsApp group. Now I would like to request Dr. Amit to conclude the session.
So I
Thanks,
should
ma'am.
stop sharing. Thank you, sir.
Thanks, ma'am, for delivering such a informative session with us, where we have covered topics like introduction to deep learning, basics of deep learning and neural networks, difference in ML and deep learning, architecture behind deep learning, how back propagation works, usage of TensorFlow, implementation of CNN, RNNs, LSTMs in sequence modeling, applications of RNN, and AI model interpretability. It was really a wonderful session. Once again, thanks ma'am, for sharing your valuable time and knowledge with us. Now we'll
Thank you so
share
much.
now we'll take immense pleasure and proud in presenting you the certificate of appreciation.
Thank you so much.
So this certificate of appreciation is proudly presented to Professor Pooja, Professor and Dean, Sharda University, Uzbekistan. Thanks, ma'am, for giving us your valuable time and knowledge. Thanks a lot.
Thank you so much, sir. I have shared my email ID. If anybody wants to collaborate for research, we are here. We'll send the content to the organizers by tomorrow. Thank you so
Thank you,
much.
ma'am. Thank you, ma'am.
Thank
Thank
you,
you to
ma'am.
all dear participants. And tomorrow we will resume the session at the same time. So please connect at least 10 minutes before starting the session. Thank you. And I am sharing the feedback form link in the chat box also. Please submit. And the same has been shared in the YouTube chat box also. The feedback of each session is mandatory to all the participants. So please don't miss the same. Thank you. And I hope you go to the link in the chat box. And now the session is over. Thank you. And I am going to end the session. Thank you to all and good night.
Thanks, sir. Good night, everyone.